In magic, the most effective misdirection doesn't hide the trick, it makes you complicit in missing it. 3I-ATLAS operates with similar elegance, an interstellar comet so chemically unusual that scientists scratch their heads, arriving so conveniently timed that conspiracy theorists reach for keyboards. Like a master illusionist who lets you see the setup while concealing the method, this cosmic visitor provides just enough mystery to generate discussion, but not enough clarity to settle debates. Is 3I-ATLAS a distraction? And if it is, what or who are we being distracted from? Tonight, we let ourselves drift into a fascinating thought experiment as we dive deep into the conspiracy theories surrounding the most perfectly timed comet in human history, a celestial visitor that arrived precisely when we needed something magnificent to look at, something that would make us forget to look elsewhere. Because sometimes the universe's sleight of hand is so smooth, you don't realize you've been watching the wrong hand until the trick is over. Stay until the end of this gentle exploration to discover what we might be missing while we're busy watching the sky. Part 1. Opening Thought Experiment. What arrives at precisely the moment we need it most? On July 1st, 2025, an automated telescope in Chile spotted something extraordinary, something that shouldn't exist, yet does. A visitor from the infinite dark between stars, catalogued as 3I-ATLAS, the third confirmed interstellar object ever detected. But here's where our bedtime story begins to whisper unsettling questions. What if this celestial wanderer isn't just a cosmic coincidence? Tonight, we embark on a thought experiment. Not science reporting, not factual claims, just speculation. The kind that makes you stare at your ceiling at 3 in the morning, wondering if the universe has a sense of timing that's just a little too perfect. 3I-ATLAS carries the official designation C/2025 N1, discovered by the Asteroid Terrestrial Impact Last Alert System Survey. It's real, it's measurable. It's heading toward perihelion, its closest approach to our Sun, on October 29th, 2025. The mathematics are clean, the trajectory predictable, the threat assessment reassuring. Earth faces no danger whatsoever. But mathematics, as we'll discover, rarely capture the full story. Imagine standing in a field at midnight, looking up at stars that seem permanent, eternal. Now imagine learning that between those fixed points, objects are racing through the void at speeds that would cross continents in heartbeats. 3I-ATLAS is moving at roughly 68 kilometers per second at perihelion, fast enough to travel from New York to Los Angeles in under 90 seconds. Yet for an interstellar object, this speed is ordinary, expected, almost boring if you're an astronomer. What makes an object interstellar isn't just speed, it's freedom. Unlike comets born in our solar system, 3I-ATLAS follows a hyperbolic trajectory. It arrived from somewhere else entirely, unbound by our Sun's gravitational embrace. It will loop around our star once, briefly, then continue into the cosmic dark, never to return. We are witnessing a cosmic drive-by, a fleeting encounter with debris from stellar neighborhoods we can barely imagine. Only 3 such visitors have been confirmed in human history. The first, 1I/Oumuamua, stunned astronomers in 2017 with its unusual acceleration and cigar-like shape. The second, 2I/Borisov, behaved more like a conventional comet when it appeared in 2019. Now we have 3I-ATLAS, arriving with chemistry that has scientists scratching their heads and conspiracy theorists reaching for their keyboards. Here's what we know from early observations. The Hubble Space Telescope has constrained its nucleus to roughly 5.6 kilometers in diameter, though it could be significantly smaller. What matters isn't the size, it's the coma, that ghostly shroud of gas and dust that betrays the object's composition. And 3I-ATLAS is wearing an unusual costume. Initial spectroscopy from the James Webb Space Telescope reveals something peculiar, a coma dominated by carbon dioxide, with a ratio of CO2 to water vapor roughly 8:1. For comparison, most comets from our solar system show the opposite preference. Water dominates, with carbon dioxide playing a supporting role. It's as if 3I-ATLAS is speaking a different chemical dialect, one that hints at formation in an alien stellar environment. But chemical oddities, however intriguing, don't necessarily spell conspiracy. The James Webb data comes with measured scientific interpretations. Perhaps 3I-ATLAS formed in a region where carbon dioxide ice was more stable than water ice. Perhaps stellar radiation processed its surface over millions of years of interstellar flight. Perhaps we're simply witnessing the signature of planetary formation around a different kind of star. The rule of tonight's journey is transparency about uncertainty. When we cite observations, perihelion dates, spectroscopic findings, trajectory calculations, we'll reference the sources. When we venture into speculation, conspiracy frameworks, hypothetical motivations, imagined scenarios, we'll label it clearly. The goal isn't to convince you of hidden truths, but to explore the space between what we know and what we wonder. Consider the timing. 3I-ATLAS was discovered in July 2025, will reach perihelion in October 2025, and will make its closest approach to Mars around October 3, 2025. Earth, meanwhile, will be on the far side of the Sun during perihelion, creating what astronomers call solar conjunction, a period when ground-based observations become nearly impossible. It's as if nature scheduled this performance for when we'd have the worst seats in the house. Or is it? The position of Earth during 3I-ATLAS's closest solar approach has already spawned whispers in online forums. They don't want us to see it clearly. The timing is too convenient. Why would an interstellar object arrive just when we can't observe it properly? These questions reveal more about human psychology than cosmic mechanics, but they're worth examining. After all, if you were designing a distraction, wouldn't you want it to be just mysterious enough to generate stories, but just elusive enough to prevent definitive answers? The institutions studying 3I-ATLAS operate with remarkable transparency. The Minor Planet Center publishes orbital updates. NASA's Jet Propulsion Laboratory provides trajectory visualizations. The Space Telescope Science Institute releases Hubble imagery. The European Space Agency coordinates ground-based observations. The SETI Institute tracks potential implications for astrobiology. This isn't the behavior of organizations orchestrating deception, it's the methodical documentation of discovery. Yet transparency itself can fuel suspicion. Why are they telling us so much? Why the stream of press releases and preprint papers? In an era when trust in institutions wavers, even openness can seem performative. The human mind craves patterns, especially during uncertain times. We live in an age of information overload, political turbulence, technological anxiety. A mysterious visitor from the stars offers a welcome reprieve from terrestrial concerns. Or does it? What if the distraction isn't accidental? What if someone, somewhere, benefits from our collective gaze turning skyward? Tonight, we'll explore these questions not as investigators seeking proof, but as philosophers examining possibility. We'll consider the mechanics of cosmic stagecraft, the psychology of distraction, and the eternal human tendency to find meaning in coincidence. We'll ask not whether 3I-ATLAS is truly a distraction, but what our fascination with that possibility reveals about us. The comet's faint coma glows somewhere in our solar system right now, releasing carbon dioxide and trace amounts of water into the solar wind. It follows laws of physics older than Earth, indifferent to our stories. Yet here we are, spinning narratives around its trajectory, reading intention into its chemistry, finding significance in its timing. Perhaps that's the most human thing of all, the ability to transform cold facts into warm mysteries, to see stories written in the sky. Whether 3I-ATLAS is natural phenomena or something else entirely, it has already succeeded in one mission, reminding us that the universe still holds surprises. But before we drift too far into the realm of speculation, let's pause and breathe. Feel your body settling into comfort. The comet will continue its journey whether we solve its mystery tonight or not. Some questions are companions, not problems. Some uncertainties are invitations to wonder, not anxiety. Tomorrow, telescopes will track 3I-ATLAS across the sky. Data will accumulate, models will refine. The story will continue unfolding at the patient pace of science. Tonight, we simply hold the questions lightly, like catching snowflakes that might melt if we grasp too tightly. The real journey starts when we admit what we don't know and find peace in the not knowing. Part 2. The nature of distraction. Human beings, it turns out, have always been remarkably good at finding cosmic villains. Give us an unexpected celestial event, add a dash of social anxiety, and we'll craft narratives that would make Hollywood screenwriters jealous. The psychology is as predictable as orbital mechanics, yet somehow we keep falling for our own patterns. History offers a catalogue of cosmic panics, each revealing more about the era's fears than the sky's intentions. In 1910, newspapers worldwide declared that Halley's Comet would poison Earth's atmosphere with cyanogen gas. Headlines screamed warnings. Entrepreneurs sold comet pills to protect against toxic gases. People sealed their windows with tape. The comet passed harmlessly, as comets do, but not before demonstrating how scientific uncertainty becomes social hysteria when filtered through sensational media. The 1910 Halley's Panic wasn't created by the comet, it was created by communication. Astronomers had detected spectral lines indicating cyanogen in the comet's tail, a genuine scientific observation. But somehow, between laboratory and living room, trace amounts of cyanogen detected in comet's tail transformed into deadly poison cloud will engulf Earth. The distortion happened in translation, not observation. 28 years later, Orson Welles demonstrated how fictional cosmic events could feel more real than reality itself. The 1938 War of the Worlds radio broadcast reportedly caused mass panic, though later research suggests the panic was largely fictional. Newspapers, competing with radio for attention, amplified stories of hysteria that probably affected far fewer people than initially claimed. We ended up with a panic about a fake invasion, layers of narrative built on narrative, like Russian dolls made of anxiety. But perhaps the most sobering example comes from 1997, when Comet Hale-Bopp became entangled with genuine tragedy. The Heaven's Gate cult interpreted the comet as a sign to abandon their physical bodies and join an alien spacecraft supposedly hidden in the comet's tail. 39 people died by suicide, convinced that a natural celestial event was actually an extraterrestrial rescue mission. The comet itself was entirely ordinary, ice and rock following gravitational laws. The meaning imposed upon it proved deadly. These historical echoes matter because they reveal how distraction narratives actually work. The sky doesn't create distractions, we do. Celestial events become cultural events through a process of projection, amplification, and social contagion. A comet appears, uncertainty multiplies, media coverage intensifies, and suddenly what was astronomy becomes anthropology. In our current media ecosystem, this process operates at digital speed. Social platforms reward engagement over accuracy. Algorithms amplify content that generates strong emotional responses. A mysterious interstellar visitor like 3I-ATLAS doesn't need conspiracy to become culturally significant, it just needs to be unusual enough to trend. And 3I-ATLAS is certainly unusual. Its carbon dioxide-rich coma defies expectations built on solar system comets. Its interstellar origin guarantees exotic chemistry. Its discovery timing, coinciding with various terrestrial tensions, provides fertile ground for suspicious minds. Its observational challenges during perihelion when Earth and the comet are on opposite sides of the Sun, create convenient information gaps that speculation rushes to fill. Yet here's the paradox. If 3I-ATLAS were truly designed as a distraction, it's either poorly executed or brilliantly subtle. A real distraction might be more dramatic, visibly spectacular, clearly threatening, obviously artificial. Instead, we have an object that requires telescopes to see, spectroscopes to analyze, and orbital calculators to understand. It's a distraction for astronomy nerds, not mass audiences. Unless that's exactly the point. Consider the psychology of modern distraction. We're not medieval peasants terrified by eclipses. We're information workers drowning in data streams, suspicious of institutions, hungry for stories that make sense of complexity. A subtle cosmic mystery might be more effective than crude spectacle. It targets the educated curious rather than the easily frightened. But let's step back from speculation and examine what distraction actually means in practice. Political scientists define it as redirecting attention from one issue to another, typically to benefit those who profit from the redirection. Military strategists call it misdirection. Make the enemy look left while you attack from the right. Magicians know it as the art of managing attention. The hand that waves is never the hand that steals. For 3I-ATLAS to function as distraction, someone would need to benefit from our collective gaze turning skyward. Who gains when humans contemplate interstellar visitors instead of terrestrial problems? Space agencies might benefit from renewed public interest in astronomy. Defense contractors might benefit from increased planetary defense funding. Science fiction writers might benefit from cultural obsession with cosmic mysteries. Or perhaps the beneficiary is more abstract. Our own psychological need for wonder in an age of overwhelming terrestrial concerns. Climate change, political polarization, technological disruption, social media anxiety, these problems feel simultaneously urgent and intractable. An interstellar visitor offers temporary escape into cosmic perspective, reminding us that Earth's struggles are tiny against the backdrop of galactic time. The attention economy thrives on novelty, and 3I-ATLAS delivers novelty in abundance. It's rare, only the third interstellar object ever confirmed. It's exotic, carrying chemical signatures from another stellar system. It's timely, arriving during a period of social and political tension. It's mysterious. Its composition challenges our models of comet formation. Most importantly, it's ambiguous. Ambiguity is the fuel of modern media cycles. Clear answers end conversations. Unanswered questions sustain them. 3I-ATLAS provides just enough data to enable speculation, but not enough to settle debates. Perfect material for the 24/7 news cycle that feeds on uncertainty. But here's what distinguishes healthy curiosity from unhealthy obsession: the ability to hold questions without demanding immediate answers. 3I-ATLAS will continue its journey whether we solve its mysteries or not. Its trajectory is fixed by physics, not opinion. Its composition reflects its origin, not our interpretations. The universe operates on timescales that dwarf human impatience. This comet began its journey toward our solar system millions of years ago, long before humans invented writing, let alone telescopes. If it carries messages, they're messages from deep time, not from contemporary conspirators. Sometimes the most radical act is accepting that not everything has hidden meaning. Sometimes a comet is just a comet, following ancient gravitational grooves carved by stellar interactions we can barely model. Sometimes the universe offers gifts without expecting anything in return except our wonder. As we prepare to explore what distraction might look like on cosmic scales, remember this: whether 3I-ATLAS is natural phenomenon or elaborate hoax, it has already succeeded in one mission. It has reminded us that space remains strange, that our solar system receives visitors from unimaginable distances, that the universe still writes surprises across the sky. The question isn't whether we're being distracted. The question is whether we're paying attention to the right things and whether we can tell the difference. Part 3. Project Bluebeam. Some conspiracy theories die quietly, forgotten footnotes in the encyclopedia of human gullibility. Others achieve a kind of immortality, resurging whenever the sky behaves strangely or when society feels particularly vulnerable to manipulation. Project Bluebeam belongs to the latter category, a 1990s conspiracy theory that refuses to stay buried, despite having no evidence to support it. The theory originated with Serge Monast, a Canadian investigative journalist who claimed to have uncovered a NASA plot to fake the Second Coming of Christ using holographic technology and satellite-based projections. According to Monast's writings, published in the mid-1990s, Project Bluebeam would unfold in 4 stages: artificial earthquakes to reveal fake archaeological discoveries, a giant space show featuring 3-dimensional holographic images of various religious figures, telepathic communication through extremely low frequency waves, and finally, a staged alien invasion to unite humanity under a single world government. It sounds absurd, and it is. No credible evidence has ever emerged supporting any aspect of Monast's claims. NASA has repeatedly debunked the theory. Holographic technology capable of creating convincing sky-wide illusions doesn't exist. The entire premise crumbles under basic technical scrutiny. Yet Project Bluebeam persists in online forums, social media groups, and conspiracy communities. Why? Because it offers something psychologically irresistible: a framework for converting helplessness into agency. When strange things happen in the sky, unexplained aerial phenomena, unusual atmospheric effects, mysterious celestial objects, Bluebeam provides a ready explanation. It's not random. Someone's in control. We can figure this out. The human brain, evolution has taught us, is exquisitely calibrated to detect patterns and anticipate threats. This served our ancestors well when patterns meant predators and threats were local and immediate. But in the modern world, pattern detection can misfire spectacularly. We see intention where none exists, coordination where coincidence suffices, and control where chaos reigns. 3I-ATLAS, through this psychological lens, becomes almost irresistible conspiracy material. An interstellar visitor arriving during political tensions, chemical composition that defies expectations, observation windows limited by solar conjunction. For minds primed to see deception, these details don't suggest natural phenomena, they suggest scripted performance. The Bluebeam framework transforms 3I-ATLAS from astronomical curiosity into potential psyop. What if this isn't a comet, but a delivery system? What if its unusual chemistry indicates artificial composition? What if its timing, discovery in July, perihelion in October, aligns with some hidden political calendar? What if its observational difficulties are features, not bugs? These questions reveal Bluebeam's seductive power. It converts scientific uncertainty into narrative certainty. Real astronomy operates in the realm of probably, likely, and consistent with. Bluebeam operates in the realm of definitely, certainly, and proof positive. It promises answers in a universe that specializes in questions, but let's examine what staging 3I-ATLAS would actually require. First, you'd need to manufacture an object that perfectly mimics a carbon dioxide-rich comet, complete with appropriate dust production rates and spectral signatures. Second, you'd need to launch it on a precisely calculated hyperbolic trajectory that appears to originate from interstellar space. Third, you'd need to coordinate its discovery by automated sky surveys that operate independently across multiple nations. Fourth, and most challenging, you'd need to ensure that every subsequent observation, by Hubble, by James Webb, by ground-based telescopes, by radar systems, by independent amateur astronomers, produces data consistent with your manufactured narrative. This would require either technological capabilities far beyond current human achievement, or a conspiracy encompassing virtually every major astronomical institution on Earth. The scale of coordination required strains credulity. The Minor Planet Center, which catalogues new discoveries, operates under international oversight. NASA's Jet Propulsion Laboratory publishes orbital solutions that can be independently verified. The Hubble Space Telescope and James Webb Space Telescope observe according to schedules planned months in advance. The SETI Institute monitors for any signs of artificial signals. Independent observatories worldwide track the object's position and brightness. For Project Bluebeam to explain 3I-ATLAS, we'd need to assume that all these institutions, across multiple countries, political systems, and scientific cultures, are either complicit in deception or successfully deceived by technology that makes Hollywood special effects look primitive. Occam's razor suggests a simpler explanation. 3I-ATLAS is what it appears to be. A chunk of ancient ice and rock, formed around a distant star, launched into interstellar space by gravitational interactions we can model but not precisely predict. Its unusual chemistry reflects its alien birthplace, not artificial engineering. Yet Bluebeam's psychological appeal transcends evidence. It offers comfort in a counterintuitive way, the comfort of believing someone, somewhere, is in control. Random cosmic events can feel more threatening than planned ones because randomness cannot be negotiated with, appeased, or predicted. If 3I-ATLAS is natural, we're just passengers in a universe that occasionally drops surprises in our laps. If it's artificial, at least someone's driving. The theory also provides intellectual superiority to believers. We see through the illusion while others accept official stories. This feeling of special knowledge can be intoxicating, especially in an age when expertise is often viewed with suspicion and when complex problems resist simple solutions. As we consider whether 3I-ATLAS could function as a Bluebeam operation, we must acknowledge the theory's fundamental unfalsifiability. Any evidence supporting the object's natural origin can be dismissed as part of the cover-up. Any evidence suggesting artificial origin can be cited as proof of the conspiracy. This makes Bluebeam not a scientific hypothesis, but a belief system, immune to contradiction because it interprets all data as confirmation. The real question isn't whether Project Bluebeam explains 3I-ATLAS. The real question is why we find such explanations appealing in the first place. What does our fascination with cosmic conspiracy theories reveal about our relationship with uncertainty, authority, and wonder? Perhaps the answer lies not in the sky, but in the mirror. We live in an age of manufactured spectacle, where corporate marketing and political theatre blur the boundaries between authentic and artificial. Is it any wonder that we've learned to suspect performance everywhere, even in the movements of ancient ice through vacuum? The stars, however, remain magnificently indifferent to our suspicions. 3I-ATLAS continues its mathematically predictable journey, releasing carbon dioxide into space according to the laws of sublimation and solar heating. Whether we interpret its presence as natural wonder or artificial distraction, it follows the same trajectory, obeys the same physics, carries the same chemical signatures. Tomorrow, astronomers will point their telescopes toward 3I-ATLAS and gather more data. They'll measure its brightness, analyze its spectrum, track its position. The measurements will either support or challenge current models of interstellar comet behavior. Science will proceed as science does, methodically, openly, imperfectly. Tonight, we'll continue our thought experiment, exploring what government agencies actually know about the sky and how much they've chosen to share with the rest of us. Part 4. Project Blue Book. The United States government spent 17 years officially investigating unexplained aerial phenomena, and the results were complicated. Project Blue Book, operating from 1952 to 1969, examined over 12,000 reports of unidentified flying objects. The vast majority, roughly 94%, received conventional explanations: weather balloons, aircraft, atmospheric phenomena, astronomical objects misidentified due to unusual viewing conditions. But 6% remained unexplained. Not explained away, not dismissed, simply unexplained. This historical context matters for our 3I-ATLAS thought experiment because it establishes something crucial. Governments do sometimes hide sky-related information, but they also sometimes share it. Blue Book's final report, released publicly, acknowledged that some aerial phenomena defied conventional explanation, while concluding that none posed national security threats or demonstrated evidence of extraterrestrial technology. The project's termination came with an interesting admission. The Air Force stated that continued investigation was unlikely to yield significant scientific breakthroughs or defense advantages. In other words, they stopped looking not because they'd solved the mystery, but because the mystery wasn't worth the resources. This pragmatic approach, study until cost exceeds benefit, offers a template for understanding how institutions really handle unexplained phenomena. Decades later, declassified documents revealed that many mysterious sightings had prosaic explanations hidden behind classification walls. The famous flying triangles over Belgium, likely early stealth aircraft tests. The bizarre maneuvers reported by military pilots, often classified experimental vehicles whose capabilities exceeded public knowledge of aerodynamics. The government wasn't hiding alien visitation, it was hiding its own technological development. This pattern of classified human technology explaining unidentified aerial phenomena suggests a framework for evaluating 3I-ATLAS. When governments choose secrecy, they typically protect capabilities, not cover up impossibilities. A government with the technology to fake an interstellar comet would have capabilities so advanced that secrecy might indeed serve national interests. But the same government would probably find more efficient ways to achieve political goals than elaborate cosmic theatre. The modern landscape of skywatching has changed dramatically since Blue Book ended. Automated surveys now scan the entire accessible sky multiple times per month. The Asteroid Terrestrial Impact Last Alert System alone processes millions of observations annually. The Catalina Sky Survey, Linear, Neowise, and dozens of other projects operate continuously, creating an interconnected web of detection that would make staging fake celestial objects extraordinarily difficult. 3I-ATLAS was discovered through this distributed system, first detected by ATLAS telescopes in Chile, then confirmed by follow-up observations worldwide, then reported to the Minor Planet Center for official cataloguing. The discovery process involved multiple independent institutions, amateur astronomers, and international coordination networks. Faking this would require infiltrating not just government space agencies but the entire global astronomy community. Yet the question of government knowledge about 3I-ATLAS remains intriguing. While civilian astronomers publish their findings openly, military space surveillance systems operate beyond public scrutiny. The United States Space Force tracks thousands of objects in Earth orbit and monitors deep space for potential threats. They almost certainly detected 3I-ATLAS before its public announcement, just as they detect most significant space objects before civilian surveys. The gap between military detection and public announcement creates fertile ground for suspicion. Why didn't they tell us earlier? What did they see that we haven't? Are there classified observations that contradict the public narrative? The answers, based on historical patterns, are probably mundane. Military space surveillance focuses on threats to satellites and spacecraft, not scientific curiosities. 3I-ATLAS posed no threat to any human assets, so it likely received minimal attention until civilian astronomers began publishing unusual spectroscopic results. The military probably filed it under interesting but irrelevant and moved on to tracking objects that actually matter for national security. This pragmatic approach to cosmic mysteries extends beyond government agencies. Professional astronomers, despite their reputation for excitement about unusual discoveries, are actually quite conservative in their interpretations. When 3I-ATLAS exhibited its carbon dioxide-rich coma, the scientific community didn't declare it artificial. They proposed natural formation mechanisms that could explain the chemistry. The James Webb Space Telescope observations, published as a preprint on RxIV, offer several plausible explanations for the unusual carbon dioxide dominance. Formation in a stellar environment where CO2 ice was more stable than water ice. Surface processing by cosmic radiation during millions of years of interstellar travel, or preferential sublimation of carbon dioxide at the object's current distance from the Sunday. These explanations might sound technical, but they reflect something important about how scientists approach anomalies. Instead of immediately assuming artificial origin, they ask, what natural processes could produce these observations? The bias toward natural explanations isn't closed-mindedness, it's intellectual humility based on centuries of discovering that nature is far more creative than human imagination. The Hubble Space Telescope images tell a similar story. The object appears as a fuzzy dot surrounded by a faint coma, exactly what you'd expect from a small comet releasing gas and dust. The size constraints, placing the nucleus at probably less than 5.6 kilometers in diameter, align with theoretical predictions for interstellar comets. Nothing in the Hubble data suggests artificial structure, unusual geometry, or non-gravitational propulsion. Even the timing of 3I-ATLAS's closest approach to Mars, around October 3, 2025, reflects orbital mechanics rather than strategic planning. The proposed high-resolution imaging science experiment observations from Mars orbit would provide unprecedented detail about the object's surface and structure. If 3I-ATLAS were artificial, this close approach would risk exposure. If it's natural, the observations would advance our understanding of interstellar material. The challenge for any hidden skies narrative is reconciling secrecy with the fundamentally public nature of astronomy. Unlike classified military programs, which can operate in hidden facilities with restricted personnel, celestial objects are visible to anyone with sufficient equipment. Amateur astronomers worldwide track 3I-ATLAS independently. University students analyze its light curves for class projects. Backyard observers photograph its faint coma through modest telescopes. This distributed observation network makes deception remarkably difficult. A fake comet would need to fool not just NASA or the European Space Agency, but hundreds of independent observers using different instruments, techniques, and analysis methods. The probability of maintaining such deception decreases exponentially with each additional observer. Yet the appeal of hidden sky narratives persists because they address genuine anxieties about transparency and control. In an era when institutions regularly deceive the public about everything from financial risks to environmental damage, why should space agencies be different? The history of government secrecy about aerial phenomena provides precedent for suspicion. The difference lies in consequences and capabilities. Hiding experimental aircraft serves clear military purposes and requires technology within plausible human development timelines. Hiding cosmic deception would serve unclear purposes and require technology that strains believability. As we drift deeper into our thought experiment, consider this. If governments possessed the capability to stage interstellar visitors, what else might they be hiding? And if they lacked such capability, why would we assume they'd choose cosmic theater over more conventional propaganda? The sky keeps its secrets until we build instruments powerful enough to reveal them. The question isn't whether secrets exist, they do. The question is whether the secrets involve 3I-ATLAS or whether this particular mystery reflects the simpler truth that the universe remains largely unknown, surprisingly creative, and occasionally generous with its wonders. Sleep comes easier when we remember that some mysteries are gifts, not conspiracies. Part 5. The question of timing. Timing, as any stage director knows, is everything. Too early, and the audience isn't ready. Too late, and the moment has passed. But when something arrives at precisely the right moment to capture maximum attention, we start wondering whether the timing was intentional. 3I-ATLAS discovered on July 1st, 2025. Perihelion on October 29th, 2025. Closest approach to Mars around October 3rd, 2025. Earth poorly positioned for observation during the object's most dramatic phase, hidden behind our sun's glare. If you were writing a script for cosmic intrigue, you couldn't ask for better dramatic structure. But let's examine what perfect timing actually means in astronomical terms. Sky surveys don't choose when to discover objects. They find them when those objects become bright enough to detect, and when observing conditions align favorably. 3I-ATLAS probably entered the inner solar system months before its discovery, but remained too faint for automated detection until solar heating began activating its surface and creating the coma that made it visible. The discovery timing, July 1st, reflects this natural brightening process rather than strategic scheduling. ATLAS telescopes scan the sky continuously, processing hundreds of thousands of observations each night. They report new objects as soon as confirmation observations establish preliminary orbits. There's no waiting for the right moment in automated survey operations. Yet the cultural timing feels significant in ways that transcend astronomy. July 2025 found humanity grappling with multiple overlapping crises, ongoing global conflicts, political polarization in major democracies, economic uncertainty, climate anxiety, and growing concerns about artificial intelligence and technological disruption. Into this context of terrestrial tension drops an interstellar visitor, mysterious, harmless, but endlessly discussable. Is this coincidence or convergence? The question assumes that good timing for distraction is somehow predictable or plannable, but social crises, like natural disasters, follow their own chaotic dynamics. Political tensions escalate and de-escalate on timescales that resist prediction. Economic anxieties emerge from complex interactions between technology, policy, and human behavior. Even the most sophisticated social engineers couldn't guarantee that July 2025 would be an optimal moment for cosmic distraction. Unless, of course, optimal moments are more common than we think. Consider the possibility that any moment in modern history might seem like perfect timing for distraction. When is human society not dealing with multiple overlapping concerns? When do news cycles not benefit from spectacular stories? When does the public not crave relief from terrestrial anxiety? The solar conjunction timing creates another layer of suspicious convenience. During perihelion, when 3I-ATLAS will be closest to the Sun and presumably most active, Earth will be positioned on the opposite side of our star. Ground-based telescopes will have difficulty observing the comet during its most dynamic phase, creating an information gap that speculation rushes to fill. From a conspiracy perspective, this timing looks suspicious, almost like someone wanted to limit detailed observation during the object's most revealing moment. From an astronomical perspective, it's simply unfortunate geometry. Earth and 3I-ATLAS happen to be positioned such that our view is blocked by the Sun during perihelion. No intelligence required, just orbital mechanics. The Mars proximity on October 3rd offers an interesting counterpoint to Earth's observational limitations. When 3I-ATLAS passes relatively close to Mars, the high-resolution imaging science experiment aboard NASA's Mars Reconnaissance Orbiter could potentially capture unprecedented detail of the object's surface and structure. If 3I-ATLAS were artificial, this close approach would risk exposure. If it's natural, the observations could answer fundamental questions about interstellar material composition. The timing of JWST observations adds another dimension to our thought experiment. The James Webb Space Telescope, humanity's most powerful infrared observatory, began studying 3I-ATLAS in August 2025, roughly 6 weeks after discovery. The resulting spectroscopy revealed the unusual carbon dioxide dominance that has puzzled scientists. But JWST's observation schedule is planned months in advance based on target accessibility and scientific priority rankings. There's no evidence that 3I-ATLAS received special scheduling consideration. Media timing follows its own dynamics, largely independent of astronomical reality. News cycles crave fresh content, particularly during slow periods when political developments fail to generate sufficient engagement. Summer and early fall often see increased coverage of science stories as other news sources diminish. The discovery of an interstellar visitor in July provides perfect content for this seasonal appetite, mysterious enough to drive clicks, safe enough to avoid panic. Social media amplification operates on even faster timescales. Unusual astronomy stories can trend within hours of publication, driven by algorithmic promotion of engaging content rather than editorial selection. 3I-ATLAS began trending on various platforms shortly after its discovery announcement, not because of coordinated promotion, but because of organic user interest in cosmic mysteries. The question of timing also depends on perspective. From human viewpoints, 3I-ATLAS's arrival seems sudden and significant. From cosmic perspectives, it represents the culmination of a journey that began millions of years ago in an alien stellar system. The object has been traveling toward this moment since before human civilization existed, following gravitational influences we can barely trace. If we zoom out further, the timing becomes even less significant. Interstellar objects probably pass through our solar system regularly, but most remain undetected because they're too small, too dark, or positioned unfavorably for current survey capabilities. 3I-ATLAS represents not a unique event, but the first of many interstellar visitors we'll likely discover as our instruments improve. The Vera Rubin Observatory, scheduled to begin full operation soon, will scan the entire accessible sky every few nights with unprecedented sensitivity. It will probably detect dozens or hundreds of interstellar objects over the next decade. When that happens, 3I-ATLAS will seem less like a mysterious exception and more like an early example of a common phenomenon. But timing concerns often mask deeper anxieties about control and predictability. We want to believe that significant events happen for reasons, that mysteries have solutions, that surprises can be explained through human agency. The alternative, that the universe occasionally delivers inexplicable gifts and unexplainable challenges according to its own inscrutable schedule, can feel unsettling. 3I-ATLAS arrived when it arrived because that's when gravitational dynamics, observational capabilities, and solar heating converged to make it detectable. Its perihelion occurs on October 29th because that's where its hyperbolic trajectory, established millions of years ago, intersects our star's gravitational field. Its observational challenges during perihelion result from Earth's orbital position, not strategic obfuscation, yet the feeling of meaningful timing persists, and maybe that's okay. Maybe our sense that the universe occasionally delivers exactly what we need, exactly when we need it, reflects something true about the relationship between consciousness and cosmos, not conspiracy, but synchronicity, not intention, but intersection. The timing question ultimately returns us to the fundamental challenge of distinguishing signal from noise in an information-saturated age. When everything feels significant, how do we identify what actually matters? When every event seems connected to every other event, how do we separate genuine patterns from projected meaning? 3I-ATLAS offers a test case for these skills. Its timing might be meaningful, coincidental, or something more subtle, a reminder that the universe operates on schedules we didn't write, following agendas we didn't design, carrying messages we're still learning to read. As October 29th approaches, we'll have opportunities to gather more data, test more hypotheses, and refine our understanding of what 3I-ATLAS actually is. Until then, we can practice holding questions without demanding immediate answers, observing phenomena without immediately explaining them away. The comet doesn't care whether we think its timing is suspicious. It continues its ancient journey, releasing carbon dioxide into space, following the mathematical certainties of orbital mechanics. Whether we interpret its presence as distraction or discovery, it remains what it has always been, a visitor from unimaginable distances, carrying stories written in chemistry we're just beginning to understand. Part 6. The Arrival. Picture this. An automated telescope scanning the Chilean sky detects something that shouldn't exist according to our comfortable assumptions about neighborhood traffic. The asteroid terrestrial impact last alert system wasn't looking for visitors from other star systems, it was hunting for rocks that might threaten Earth. Instead, it found something following a trajectory that defies solar system citizenship. 3I-ATLAS emerged from the data streams like a ghost materializing in a crowded room. One night, empty coordinates. The next night, a faint smudge moving too fast and in the wrong direction. Within days, orbital calculations confirmed what seemed impossible. This object wasn't born here. It arrived from interstellar space, unbound by our sun's gravitational embrace, following a hyperbolic path that would carry it back into the cosmic dark after a brief gravitational dance with our star. The mathematics of arrival are simultaneously elegant and unsettling. Objects in closed, elliptical orbits return periodically, Halley's Comet every 76 years, Comet Hale-Bopp every 4,000 years. But hyperbolic trajectories are one-way tickets. 3I-ATLAS has never been here before, and will never return. We're witnessing a singular event, a cosmic moment that exists exactly once in the history of our solar system. Compared to its predecessors, 3I-ATLAS arrived during humanity's golden age of space-based observation. When 1I/Oumuamua surprised us in 2017, we caught it leaving, too late for detailed study, too distant for comprehensive analysis. We learned that it accelerated slightly as it moved away from the Sun, suggesting outgassing or some other non-gravitational force, but we couldn't determine its composition or internal structure. 2I/Borisov, discovered in 2019, behaved more like a conventional comet despite its interstellar origin. It produced a coma rich in water vapor and dust, following predictable patterns as solar heating sublimated its surface ice. But even Borisov revealed surprises. Its carbon monoxide to water ratio differed from solar system comets, hinting at formation in an alien environment with different chemical abundances. 3I-ATLAS combines the mystery of Oumuamua with the observational accessibility of Borisov, but adds chemical puzzles that neither predecessor presented. The James Webb Space Telescope, operational since 2022, provides spectroscopic capabilities that weren't available for earlier interstellar visitors. We can now analyze the composition of alien ice in real time, watching as solar heating transforms ancient frozen gases into observable vapor signatures. The initial JWST observations, published as a preprint in August 2025, reveal something unexpected. 3I-ATLAS's coma contains roughly 8 times more carbon dioxide than water vapor. Most solar system comets show the opposite ratio. Water dominates, with carbon dioxide playing a supporting role. It's as if this visitor speaks a different chemical language, one that reflects formation around a star with different properties than our Sunday. This chemical signature raises fascinating questions about stellar neighborhood diversity. Different types of stars create different planetary formation environments. Red dwarf stars, which comprise roughly 75% of all stars in our galaxy, might produce planetary systems where carbon dioxide ice is more abundant than water ice. 3I-ATLAS could be our first direct sample of materials from such an exotic stellar environment. The Hubble Space Telescope has provided complementary observations, constraining the object's nucleus to probably less than 5.6 kilometers in diameter, though it could be significantly smaller. The uncertainty reflects fundamental limits of Earth-based observation. We're trying to measure a dark, distant object by the faint light it reflects and the subtle glow of its coma. It's like estimating the size of a candle by studying its flame from across a football stadium, but size uncertainty, while frustrating for astronomers, doesn't necessarily indicate anything suspicious. Determining the precise dimensions of small, distant objects has always challenged observational astronomy. The Hubble constraints represent the best possible measurements given current technology and the object's distance from Earth. The speed of 3I-ATLAS near perihelion, approximately 68 kilometers per second, provides another data point for understanding its nature. This velocity is consistent with gravitational acceleration from interstellar approach speeds of roughly 26 kilometers per second, typical for objects unbound from stellar systems. The numbers align perfectly with expectations for natural interstellar comets. Yet speed also creates observational challenges. 68 kilometers per second means 3I-ATLAS crosses the diameter of Earth in roughly 3 minutes. Ground-based telescopes must track rapidly to maintain observation, limiting exposure times and reducing image quality. Space-based telescopes like Hubble and JWST can track more smoothly, but even they face constraints when observing fast-moving targets. The Mars encounter on October 3rd presents a unique opportunity to bypass Earth-based observational limitations. The high-resolution imaging science experiment, capable of resolving features smaller than 1 meter on the Martian surface, could potentially capture unprecedented detail of 3I-ATLAS's nucleus and coma structure. These observations might settle questions about the object's composition, internal structure, and activity patterns. However, high-rise observations depend on precise targeting and favorable illumination conditions. The encounter geometry must align perfectly. Mars, 3I-ATLAS, and the Sun positioned such that reflected sunlight illuminates the comet's surface, while high-rise maintains clear sight lines. Astronomical timing is rarely convenient for human schedules. The arrival story of 3I-ATLAS also reflects the maturation of automated sky surveys. Unlike historical comet discoveries, which often depended on dedicated human observers scanning the sky night after night, modern surveys operate continuously with minimal human intervention. ATLAS telescopes capture millions of observations each night, processing them through algorithms that flag potential asteroid and comet candidates for human review. This automated approach means discoveries happen according to observational thresholds rather than human intuition. 3I-ATLAS became detectable when solar heating began activating its surface, not when astronomers decided to look for it. The timing of discovery reflects physics, not psychology. Yet the human element hasn't disappeared entirely. Someone still had to recognize the significance of ATLAS's detection, calculate preliminary orbits, and coordinate follow-up observations. Someone had to realize that the orbital solution indicated interstellar origin and alert the global astronomy community. Someone had to request telescope time on Hubble and JWST for detailed study. These human decisions introduce potential points of coordination or control. Could the discovery announcement have been delayed to align with political timing? Could the observational priorities have been influenced by non-scientific considerations? Could the interpretation of spectroscopic data reflect institutional biases rather than objective analysis? The transparency of modern astronomy makes such coordination difficult, but not impossible. All discovery announcements go through the Minor Planet Center, which operates under international oversight. All major observational results appear in publicly accessible databases or peer-reviewed publications. All orbital calculations can be independently verified by anyone with sufficient mathematical training. But transparency itself can be strategic. If you wanted to stage a cosmic distraction, operating through legitimate scientific channels might be more effective than obvious deception. Use real telescopes, real data, real scientists. Just ensure the data tells the story you want told. The challenge with this approach is maintaining consistency across multiple independent observations and analysis teams. 3I-ATLAS is being studied by NASA, the European Space Agency, university researchers, amateur astronomers, and private observatories worldwide. Each group brings different instruments, techniques, and theoretical frameworks to the analysis. Coordinating deception across such a distributed network would require either unprecedented cooperation or technology so advanced that it makes conspiracy theories seem mundane by comparison. As October 29th approaches, the timing question will face its ultimate test. Will 3I-ATLAS continue behaving like a natural comet, following predictable patterns of outgassing and brightness variation? Will unexpected phenomena emerge that challenge conventional explanations? Will the observations near Mars reveal surface features consistent with ancient ice and rock, or something more puzzling? The answer lies in data that doesn't exist yet, observations that haven't been made, measurements that await better viewing geometry. Until then, we're left with timing that feels meaningful but might be meaningless, patterns that suggest intention but could reflect coincidence. Perhaps the most unsettling possibility is that the timing is both coincidental and perfect, that the universe occasionally delivers exactly what we need to examine our assumptions about reality, agency, and meaning. Not because someone planned it, but because consciousness and cosmos occasionally align in ways that feel like design but reflect deeper patterns we don't yet understand. Sleep comes easier when we remember that perfect timing might be more common than perfect planning, and that the universe has been surprising conscious observers for far longer than conscious observers have existed to be surprised. Part 7. Who would gain? In the theatre of cosmic conspiracy, every mystery needs a motive, and every motive needs a beneficiary. So let's ask the uncomfortable question. If 3I-ATLAS were indeed a carefully orchestrated distraction, who profits from humanity's collective gaze turning skyward? The obvious suspects line up like characters in a political thriller. Government agencies might benefit from redirecting public attention away from terrestrial failures, failed policies, broken promises, inconvenient scandals. A mysterious interstellar visitor provides perfect cover for news cycles, dominating headlines that might otherwise focus on more damaging stories. Space agencies themselves present another intriguing possibility. NASA's budget depends on public interest and congressional support. The European Space Agency competes for funding across member nations with varying priorities. A genuine interstellar mystery validates their mission statements, justifies their expensive instruments, and potentially unlocks additional resources for planetary defense and deep space exploration. Corporate interests add another layer of potential motivation. Aerospace contractors working on planetary defense systems benefit from heightened awareness of cosmic threats. Entertainment companies profit from public fascination with space mysteries. Even telescope manufacturers see increased sales when amateur astronomers get excited about accessible celestial targets. But these mundane explanations assume that orchestrating 3I-ATLAS would be worth the enormous cost and complexity involved. Creating a convincing interstellar comet would require technological capabilities that far exceed any known human achievement. The resources needed to develop, deploy, and coordinate such a project would probably exceed the benefits of temporary distraction. Unless the benefits aren't temporary, unless someone's playing a much longer game, consider the educational impact of 3I-ATLAS. Every time an unusual space object captures public attention, enrollment in astronomy and physics programs increases. More students pursue STEM careers, more funding flows towards space research, more political support builds for space exploration initiatives. A carefully timed cosmic mystery could reshape an entire generation's relationship with science and technology. The international cooperation required to study 3I-ATLAS also strengthens bonds between space agencies, universities, and research institutions worldwide. Joint observations, shared data, coordinated analysis, these activities build the kind of collaborative networks that transcend political boundaries. If someone wanted to encourage global scientific cooperation, staging a mystery that required international coordination would be remarkably effective. Yet this analysis assumes that positive outcomes indicate intentional design, a logical fallacy that conspiracy thinking often employs. Good consequences don't necessarily imply hidden planning. Sometimes beneficial results emerge from natural events that humans choose to interpret constructively. The scientific community's response to 3I-ATLAS demonstrates this principle clearly. Rather than sensationalizing the object's unusual properties, astronomers have proposed measured explanations based on established physics. The carbon dioxide-rich coma could result from formation in a stellar environment where CO2 ice was more stable than water ice. The apparent size constraints might reflect measurement limitations rather than unusual physical properties. Professional astronomers, despite their excitement about rare discoveries, maintain conservative interpretive frameworks precisely because their reputations depend on accuracy over sensationalism. They know that extraordinary claims require extraordinary evidence, and that preliminary observations of distant objects often prove misleading upon closer examination. The SETI Institute's involvement in 3I-ATLAS observations adds another dimension to the beneficiary question. Organizations dedicated to searching for extraterrestrial intelligence obviously benefit from public interest in potential alien artifacts. But SETI researchers have been notably cautious about 3I-ATLAS, emphasizing natural explanations while acknowledging the object's unusual properties. This restraint suggests that even groups with clear incentives to promote alien interpretations recognize the dangers of over-interpreting limited data. False alarms damage credibility and reduce public trust in scientific institutions. Better to understate possibilities than overstate certainties. The timing of 3I-ATLAS's discovery also benefits educational outreach programs. Science museums, planetariums, and astronomy clubs worldwide have incorporated the interstellar visitor into their programming. Children who might never have considered space science now ask questions about hyperbolic orbits and carbon dioxide sublimation. Teachers who struggled to make astronomy relevant suddenly have a tangible mystery to explore with their students. But educational benefits could also serve more subtle agendas. Increased public interest in space science might support funding for military space programs disguised as civilian research. Enhanced planetary defense capabilities could enable offensive operations as easily as defensive ones. International scientific cooperation might facilitate intelligence gathering under academic cover. These possibilities highlight the challenge of distinguishing legitimate scientific interest from potential hidden agendas. The same observations that advance our understanding of interstellar material also demonstrate our ability to detect and track fast-moving objects in deep space. The same technologies that study comet composition could be adapted for military reconnaissance or weapons targeting. Yet this dual-use potential exists for virtually all space technology. The rockets that launch scientific satellites can also deliver military payloads. The The telescopes that search for exoplanets can also track enemy spacecraft. The communication networks that coordinate international research can also facilitate intelligence operations. If we assume conspiracy in every space program because of dual-use potential, we'd have to abandon space exploration entirely. More productively, we can acknowledge that complex technologies serve multiple purposes while evaluating specific programs based on their stated goals, demonstrated behaviors, and observable outcomes. The institutions studying 3I-ATLAS have generally behaved consistently with their scientific missions. They've published data openly, shared observational resources internationally, and proposed natural explanations for unusual findings. Their communications emphasize uncertainty and encourage continued observation rather than claiming definitive answers. This behavior pattern aligns more closely with genuine scientific inquiry than with orchestrated distraction. Effective distractions typically provide clear narratives that discourage further investigation. 3I-ATLAS has generated more questions than answers, more requests for telescope time than satisfied curiosity. Perhaps the most profound beneficiary of 3I-ATLAS isn't any human institution but human consciousness itself. In an age of manufactured entertainment and artificial experiences, a genuine cosmic mystery offers authentic wonder. The object's interstellar origin connects us to scales of space and time that dwarf terrestrial concerns. Its chemical signature reminds us that the universe contains surprises we haven't yet imagined. The distraction, if it exists, might be positive, distracting us from cynicism toward curiosity, from local anxieties toward cosmic perspective, from human conflict toward universal questions. Not all distractions mislead. Some redirect attention toward what matters most. The beneficiaries of 3I-ATLAS in the end might be all of us. Not because someone planned it that way, but because consciousness occasionally encounters phenomena that expand its horizons and challenge its assumptions. Not because the universe cares about human politics, but because human politics becomes less consuming when viewed from interstellar perspective. Tonight, as we drift toward deeper speculation about cosmic mechanics, remember that the most important question isn't who gains from 3I-ATLAS. The most important question is what we choose to gain from encountering mystery itself. Part 8. Methods of placement. Let's venture into purely speculative territory now, with appropriate warning labels attached. If someone wanted to stage an interstellar visitor, how would they even attempt such an audacious deception? We're entering the realm of science fiction, physics, and engineering fantasy, but the thought experiment might illuminate why 3I-ATLAS almost certainly isn't what conspiracy theories suggest. The first challenge would be manufacturing the object itself. 3I-ATLAS exhibits spectroscopic signatures consistent with ancient ice, carbon dioxide, water, carbon monoxide, and trace organic compounds formed in the cold vacuum between stars. Creating artificial ice with these properties would require understanding chemical processes that operate over millions of years in radiation environments we can barely simulate. The engineering would be staggering. You'd need to compress and freeze gases in ratios that match alien stellar formation conditions. You'd need to artificially age the surface through radiation exposure equivalent to millions of years of cosmic ray bombardment. You'd need to embed dust particles and organic compounds in patterns that convince infrared spectroscopy and mass spectrometry analysis. Even assuming such manufacturing capabilities, you'd face the delivery problem. 3I-ATLAS arrived from the direction of the constellation Lynx with an approach velocity of roughly 26 kilometers per second, typical for interstellar objects, but requiring enormous energy to achieve artificially. Accelerating even a small object to interstellar speeds demands propulsion systems that dwarf any current human technology. The energy requirements are literally astronomical. Moving a 5-kilometer diameter object to 26 kilometers per second would require energy equivalent to multiple hydrogen bombs, applied with precision that doesn't vaporize the payload. Current human spacecraft achieve maximum velocities of roughly 17 kilometers per second using gravitational assists from multiple planets. Reaching true interstellar speeds remains far beyond our engineering capabilities. But let's assume breakthrough propulsion technology, fusion ramjets, antimatter drives, or exotic physics we haven't discovered yet. Even then, you'd face the trajectory problem. 3I-ATLAS's approach vector suggests origin from the direction of Lynx, roughly 400 light-years away. Launching an artificial object from that distance would require predicting solar system planetary positions centuries in advance and compensating for gravitational perturbations from dozens of stellar neighbors. The precision required exceeds human computational ability by orders of magnitude. We can barely predict Earth's weather 2 weeks ahead, yet staging 3I-ATLAS would require predicting galactic gravitational interactions across centuries. The mathematics alone suggest that anyone capable of such engineering would possess capabilities so advanced that elaborate deception becomes unnecessary. Alternative staging scenarios might involve shorter delivery distances. Instead of launching from interstellar space, perhaps someone positioned 3I-ATLAS in the outer solar system years ago, then gave it a gravitational nudge to simulate interstellar arrival. This approach would reduce energy requirements and improve trajectory control. But it would also create observable evidence. Objects lurking in the outer solar system occasionally pass in front of background stars, creating brief occultation events detectable by automated sky surveys. They reflect sunlight, however faintly, creating trackable signatures. They interact gravitationally with known planets, creating perturbations that careful observation can detect. No such evidence exists for 3I-ATLAS. Its trajectory, when extrapolated backward, leads cleanly into interstellar space without suspicious loitering in solar system suburbs. Either it genuinely arrived from outside, or whoever staged its appearance achieved technological perfection that leaves no traces. The observational challenges facing 3I-ATLAS also argue against artificial origin. During perihelion, when the object will be most active and potentially most revealing, Earth will be poorly positioned for observation due to solar conjunction. If someone wanted to showcase their technological achievement, they'd probably choose geometry that maximized rather than minimized visibility. Unless limited visibility is itself the goal. If 3I-ATLAS were designed to generate mystery rather than provide answers, difficult observation conditions would serve that purpose perfectly. Just enough data to confirm something unusual, not enough data to determine exactly what. The Mars encounter on October 3rd provides an interesting test of this hypothesis. The high-resolution imaging science experiment aboard Mars Reconnaissance Orbiter could potentially resolve surface features smaller than 10 meters across if viewing conditions align favorably. If 3I-ATLAS were artificial, this close approach would risk exposing non-natural structures or compositions. Natural comets show surface features consistent with thermal processing, impact cratering, and sublimation patterns. Artificial objects might show different signatures, geometric regularity, unusual material boundaries, or structural elements that suggest manufacturing rather than accretion. The high-rise observations, if they occur, could provide definitive evidence either way. But definitive evidence assumes that artificial objects would necessarily look artificial at high resolution. Advanced manufacturing might produce surfaces indistinguishable from natural ice and rock. Sophisticated deception might anticipate close observation and prepare accordingly. This leads to the unfalsifiability problem that plagues all conspiracy theories. No observation can definitively prove natural origin because any observation could potentially be explained as evidence of sufficiently advanced deception. The conspiracy theory becomes immune to contradiction by postulating capabilities that exceed any conceivable refutation. The scientific community addresses this problem through Occam's razor, preferring explanations that require fewer unsupported assumptions. 3I-ATLAS's properties can be explained through natural processes we understand: comet formation in alien stellar environments, chemical processing during interstellar travel, and predictable responses to solar heating. These explanations require no technological breakthroughs, no coordinated deception, no hidden agendas. Alternative explanations requiring artificial origin must postulate propulsion systems we haven't invented, manufacturing techniques we can't imagine, coordination capabilities we can't achieve, and motivations we can't clearly identify. While not impossible, these explanations multiply assumptions beyond practical necessity. The question of placement methods ultimately returns us to the fundamental challenge of distinguishing possible from plausible. Many things are technically possible that remain practically implausible. Artificial interstellar comets fall into this category, conceivable in principle, unlikely in practice. As we continue our thought experiment, moving from mechanics toward motivations, remember that the most elaborate staging scenarios often reflect human creativity more than cosmic reality. We excel at imagining complex deceptions because we live in a world where complex deceptions actually occur. But the universe, thankfully, tends towards simpler explanations. Not because it lacks imagination, but because simplicity works. Gravity shapes galaxies through straightforward mathematics. Stars forge elements through well-understood fusion processes. Comets sublime through predictable thermal dynamics. 3I-ATLAS, whatever its ultimate origin, follows these simple rules. It reflects sunlight according to optical physics. It releases gases according to sublimation thermodynamics. It follows trajectories according to gravitational mechanics. Whether these simple rules reflect natural processes or sophisticated mimicry depends on assumptions we can examine but cannot definitively resolve with current observations. The placement question, like the timing question, ultimately asks whether we trust the universe to be stranger than human imagination, or whether we believe human imagination has learned to mimic universal strangeness. Both possibilities remain open as October 29th approaches. Part 9. Alien Theories, The Dark Forest. In Liu Cixin's science fiction masterpiece, The Three-Body Problem, the universe operates according to a terrifying logic called the Dark Forest Hypothesis. Every civilization, upon achieving interstellar communication capability, faces a deadly choice: remain silent or risk annihilation. The galaxy becomes a dark forest where every civilization is an armed hunter, moving quietly through the trees, knowing that revealing their position invites destruction from better armed neighbors. The dark forest assumes that resources are finite, civilizations are exponentially expanding, and good intentions are impossible to verify across interstellar distances. Better to eliminate potential threats preemptively than risk being eliminated by them. The hypothesis explains the Fermi paradox, why we haven't detected alien civilizations despite the galaxy's age and size, by suggesting that successful civilizations have learned to hide. But what if the dark forest operates more subtly than Liu Cixin imagined? What if advanced civilizations don't destroy emerging species but manipulate them? What if interstellar objects like 3I-ATLAS aren't weapons but distractions, designed to misdirect developing civilizations' attention away from dangerous knowledge or inconvenient truths? This variation of dark forest thinking transforms 3I-ATLAS from astronomical curiosity into psychological warfare. The unusual carbon dioxide chemistry becomes a signature, a calling card from civilizations who want us to know we're being watched without revealing their technological capabilities. The perfect timing becomes evidence of monitoring. They know when we need distracting and provide cosmic entertainment accordingly. The beauty of distraction-based dark forest strategy lies in its deniability. Unlike overt intervention, which would violate hypothetical non-interference protocols, distraction operates through natural-seeming phenomena. We discover objects that challenge our understanding just enough to generate discussion, but not enough to provide definitive answers. We develop theoretical frameworks that expand our cosmic perspective while steering us away from dangerous developments. Under this interpretation, 3I-ATLAS serves multiple strategic functions. It validates our astronomical capabilities while demonstrating their limitations. It encourages international cooperation while consuming resources that might otherwise support military research. It provides safe mystery that satisfies human curiosity without revealing information that might accelerate our technological development beyond safe parameters. Yet, applying dark forest logic to 3I-ATLAS encounters immediate problems. Current evidence overwhelmingly supports natural origin. The object's hyperbolic trajectory matches expectations for gravitational dynamics in stellar neighborhoods. Its composition, while unusual, falls within plausible ranges for materials formed around different types of stars. Its behavior follows predictable patterns of comet outgassing and thermal response. The James Webb Space Telescope observations published as preprint research offer prosaic explanations for the unusual carbon dioxide dominance. Formation near a CO2 ice line, where carbon dioxide freezes more readily than water, could naturally produce the observed chemistry. Alternatively, millions of years of cosmic radiation exposure might preferentially process surface water while preserving deeper carbon dioxide deposits. These natural explanations don't require alien intervention, advanced technology, or hidden agendas. They simply require that the universe be larger and more chemically diverse than our solar system experience suggests. Given that our solar system represents a sample size of 1, unusual chemistry in interstellar visitors should be expected rather than surprising. The SETI Institute, despite its mission to detect extraterrestrial intelligence, has approached 3I-ATLAS with scientific conservatism. Their researchers acknowledge the object's unusual properties while emphasizing natural interpretations. They've scheduled radio observations to search for artificial signals, but express no expectation of finding them. This measured response illustrates how actual scientists approach potential alien artifacts. Despite institutional incentives to discover extraterrestrial technology, SETI researchers maintain rigorous evidential standards. They understand that false positives damage credibility more than false negatives damage discovery programs. Dark forest scenarios also struggle with the observation problem. If advanced civilizations wanted to manipulate emerging species through staged cosmic events, they'd need to predict and control our observational capabilities. But human astronomy develops chaotically, driven by technological breakthroughs, funding availability, and individual research interests that resist prediction. The timing of James Webb Space Telescope operations, for example, depends on complex factors including instrument calibration, target scheduling, and competing research priorities. Coordinating 3I-ATLAS's arrival with JWST's operational readiness would require predicting human technological development with impossible precision. Moreover, dark forest strategies assume that distraction serves alien interests. But what interests might those be? Preventing human expansion into space? Slowing scientific development? Encouraging resource consumption on non-threatening research? The motives remain unclear because we lack sufficient information about alien psychology, technology, or strategic goals. Real dark forest scenarios, as conceived by scientists rather than science fiction writers, probably operate through stealth rather than spectacle. Advanced civilizations capable of interstellar manipulation would likely employ surveillance techniques we couldn't detect, communication methods we couldn't intercept, and intervention strategies we couldn't recognize. 3I-ATLAS, by contrast, advertises its presence through visible light reflection, announces its composition through infrared emission, and reveals its trajectory through gravitational mechanics. If it were an alien probe, it would be a remarkably conspicuous one, more like a diplomatic envoy than a covert operative. The dark forest interpretation also assumes that emerging civilizations like humanity pose some kind of threat to established galactic powers. But our current technological capabilities barely extend beyond our planetary neighborhood. We've sent exactly 5 artificial objects beyond the heliosphere, and none travel fast enough to reach other star systems within reasonable timeframes. Perhaps the real dark forest isn't populated by competing civilizations, but by competing interpretations of ambiguous phenomena. We're hunters stalking meaning through forests of data, armed with theoretical frameworks that might illuminate or mislead. 3I-ATLAS becomes our quarry, an elusive target that reveals more about our hunting strategies than about itself. The forest grows darker as we realize that our search for alien intention might be preventing us from seeing alien indifference. What if 3I-ATLAS carries no message because its creators never imagined conscious observers would develop the technology to detect and analyze it? What if we're eavesdropping on conversations never intended for our ears? Or what if the message is simpler than we expect? The universe contains more variety than any single planetary perspective can encompass, and sometimes that variety visits us in forms we're not yet equipped to fully understand. As we prepare to explore an even more speculative framework, the Great Filter, consider that dark forest scenarios might be comforting illusions. They assume the universe contains conscious intention, even if that intention is hostile. The alternative, that consciousness is rare, communication is difficult, and most phenomena reflect indifferent physical processes, might be more unsettling than any conspiracy. Sleep comes easier when we remember that being ignored by the universe might be a blessing rather than an oversight. Part 10. Alien Theories, the Great Filter. Somewhere between the emergence of life and the colonization of galaxies lies a bottleneck so severe that it filters out virtually all potential civilizations. This is the Great Filter, economist Robin Hansen's elegant solution to the Fermi paradox, his answer to why the universe seems so empty despite having existed long enough for intelligence to spread among the stars. The filter could be behind us, the emergence of self-replicating molecules, the evolution of complex cells, the development of intelligence, the invention of technology. If we've already passed the Great Filter, we might be alone, not because we're doomed, but because we're extraordinarily lucky survivors of evolutionary challenges that destroy most potential civilizations before they achieve spaceflight. Or the filter could be ahead of us. Self-destruction through warfare, environmental collapse, technological risks we haven't yet encountered, or expansion challenges that prove insurmountable despite our cosmic ambitions. If the filter lies in our future, 3I-ATLAS might be arriving at precisely the moment we need to make crucial decisions about our species' survival. Under Great Filter thinking, interstellar objects become potential test instruments, cosmic exams designed to evaluate whether emerging civilizations possess the wisdom, cooperation, and technological sophistication necessary to avoid self-destruction. 3I-ATLAS's unusual properties transform from astronomical curiosities into evaluation criteria. Consider the skills required to properly study 3I-ATLAS: international cooperation among competing space agencies, resource allocation for purely scientific rather than immediately practical research, technological integration across multiple advanced instrument platforms, and public communication that balances transparency with responsible uncertainty management. These capabilities might correlate with civilizational maturity. Our response to 3I-ATLAS so far suggests mixed results on this hypothetical cosmic exam. The positive indicators are encouraging. NASA, the European Space Agency, and other institutions have shared data openly rather than hoarding it competitively. The Hubble Space Telescope and James Webb Space Telescope have coordinated observations despite demanding scheduling pressures. The international astronomy community has collaborated on analysis and interpretation. But the negative indicators are concerning. Online communities have immediately gravitated toward conspiracy theories rather than scientific explanations. Media coverage has emphasized mystery and speculation over measured uncertainty. Social media algorithms have amplified sensational interpretations while burying technical analysis. We've demonstrated our ability to detect and study interstellar visitors, but also our tendency to mythologize what we can't immediately explain. A sufficiently advanced civilization designing great filter tests might find our mixed performance revealing. We possess impressive technological capabilities, but questionable wisdom about their application. We can coordinate international space missions, but struggle to coordinate international responses to terrestrial challenges. We can analyze alien chemistry, but can't agree on how to interpret the results. The carbon dioxide-rich composition of 3I-ATLAS could function as a particularly clever test parameter. Understanding why an interstellar comet contains more CO2 than water requires knowledge of stellar formation environments, planetary system architecture, and chemical processing in deep space radiation fields. Civilizations that achieve this understanding demonstrate scientific maturity that might correlate with survival probability. Alternatively, the composition could test our response to unexpected data. Do we immediately assume artificial origin when observations don't match models? Do we adapt our theories to accommodate new evidence? Do we maintain scientific skepticism while remaining open to surprising possibilities? Our reaction to chemical anomalies might indicate whether we're ready for the larger surprises that await expanding civilizations. The timing of 3I-ATLAS's arrival, viewed through great filter thinking, becomes another evaluation metric. The object was discovered during a period of significant terrestrial stress, global conflicts, political polarization, technological disruption, environmental degradation. How we balance cosmic curiosity with planetary responsibilities might indicate our readiness for the challenges that await spacefaring civilizations. The observational difficulties created by solar conjunction during perihelion add another test dimension. Can we maintain scientific interest and coordinate international observations despite limited data availability? Do we fill information gaps with speculation or patient investigation? Can we tolerate uncertainty long enough to gather better evidence? Early indications suggest we're performing reasonably well. Professional astronomers have maintained focus on observational goals rather than sensational speculation. The proposed Mars-based observations using HIRES demonstrate creative problem-solving when Earth-based observation becomes difficult. The continued JWST monitoring shows commitment to long-term data collection despite immediate answers. But great filter tests might operate on longer timescales than individual discoveries. Perhaps 3I-ATLAS is just the first of many interstellar visitors we'll encounter as our detection capabilities improve. The Vera Rubin Observatory, beginning full operations soon, will scan the entire accessible sky every few nights with unprecedented sensitivity. We'll probably discover dozens or hundreds of interstellar objects over the next decade. How we handle this transition from interstellar rarity to interstellar routine might determine whether we pass or fail the filter test. Will we maintain scientific rigor when cosmic mysteries become commonplace? Will we develop institutional frameworks capable of studying multiple unusual objects simultaneously? Will we resist the temptation to sensationalize every anomaly? The Great Filter Framework also raises uncomfortable questions about our search for extraterrestrial intelligence. If advanced civilizations use interstellar objects to evaluate emerging species, our efforts to detect alien radio signals might be missing the actual communication channel. Instead of listening for intentional messages, we might need to learn to read the chemical signatures, trajectories, and timing of cosmic visitors. 3I-ATLAS's carbon dioxide dominance could encode information about its origin star's spectral class, planetary formation environment, or chemical evolution timeline. The object's approach vector might indicate the direction toward inhabited stellar systems. Its arrival timing might reflect monitoring of human technological development rather than coincidental gravitational dynamics. Yet, these interpretations require assuming that interstellar travel is sufficiently advanced and affordable that civilizations routinely deploy objects across hundreds of light years for evaluation purposes. The energy and resource requirements for such programs would exceed the economic output of entire planetary civilizations. Unless the economics of interstellar travel are radically different than our current understanding suggests, using comets as test instruments seems prohibitively expensive even for advanced civilizations. The Great Filter framework ultimately forces us to confront an uncomfortable possibility. We might be alone not because intelligence is rare, but because intelligence is unstable. Civilizations might regularly achieve the technological capability to detect interstellar visitors, analyze their composition, and speculate about their origins, only to destroy themselves before developing the wisdom to interpret such discoveries constructively. Our response to 3I-ATLAS might be diagnostic. Are we mature enough to study cosmic mysteries without fragmenting into competing conspiracy theories? Can we maintain international cooperation when faced with phenomena that challenge our understanding? Do we possess the emotional stability to encounter the unknown without immediately assuming malevolent intent? The carbon dioxide chemistry that makes 3I-ATLAS chemically unusual might be testing our scientific literacy. Can we distinguish between genuinely anomalous data and data that merely conflicts with limited experience? Do we adapt our models when observations challenge expectations, or do we adapt our observations to protect existing models? The observational challenges created by solar conjunction might be testing our patience and persistence. Can we sustain research programs when immediate results are unavailable? Do we maintain funding for long-term studies that might not yield answers within political or academic career cycles? Can we resist the temptation to fill data gaps with speculation? Most importantly, the very existence of 3I-ATLAS might be testing our cosmic perspective. Can we acknowledge our position as one species on one planet, orbiting one star in one galaxy, without either inflating our importance or deflating our possibilities? Can we remain curious about interstellar visitors without assuming they're necessarily connected to our local concerns? These questions matter because they illuminate potential failure modes that could constitute great filter scenarios. Civilizations might develop the technology to detect interstellar objects, but lack the wisdom to study them scientifically. They might achieve international coordination for space projects, but fragment over interpretation of ambiguous data. They might build powerful instruments for cosmic observation, but use them primarily to validate existing beliefs rather than challenge assumptions. The Great Filter might not be a single catastrophic event, but a gradual process of intellectual and social decay, the slow replacement of evidence-based reasoning with narrative-based thinking, the erosion of institutional trust that makes coordination impossible, the triumph of emotional satisfaction over empirical accuracy. If 3I-ATLAS is indeed a great filter test, our performance remains in progress. We've demonstrated impressive technological capabilities and encouraging international cooperation, but we've also revealed persistent tendencies toward conspiracy thinking and immediate gratification. We want answers faster than the universe provides them, certainty greater than the evidence supports. The test results won't be available until long after 3I-ATLAS has departed our solar system. Future decades will reveal whether our encounter with this interstellar visitor strengthened or weakened our capacity for scientific reasoning, international cooperation, and patient investigation of cosmic mysteries. Perhaps the most profound implication of great filter thinking isn't that we're being tested by aliens, but that we're testing ourselves. Every encounter with the unknown reveals something about our intellectual maturity, emotional stability, and collective wisdom. 3I-ATLAS provides a mirror in which we can examine our reflection and ask whether we like what we see. The universe doesn't care whether we pass or fail its implied tests. Stars will continue burning, galaxies will continue expanding, and interstellar objects will continue following gravitational trajectories regardless of human interpretation. But we care, and our caring might be what transforms cosmic coincidence into great filter evaluation. As we drift toward philosophical territories, remember that the most important question isn't whether 3I-ATLAS represents alien testing, but whether we're ready for whatever we might discover when we finally answer that question definitively. Sleep comes easier when we remember that tests, whether cosmic or terrestrial, often teach us more through the taking than through the scoring. Part 11. Why distract humanity? If we're going to entertain the possibility that 3I-ATLAS serves as cosmic distraction, we need to examine the fundamental question: why would anyone want to distract humanity, and from what? The answers reveal as much about our anxieties as they do about potential cosmic machinations. The most obvious target for distraction is unity itself. Humanity in 2025 stands at a curious juncture, technologically capable of global coordination, yet politically fragmented into competing narratives about everything from climate change to artificial intelligence. We possess communication networks that could theoretically enable species-wide cooperation, but we use them primarily to amplify disagreement and tribal identification. A sufficiently sophisticated observer might recognize this pattern as historically dangerous. Previous civilizations that achieved planet-spanning communication without developing planet-spanning wisdom often consumed themselves in conflicts that their technology made catastrophically efficient. Perhaps 3I-ATLAS arrives precisely when we need reminding that larger perspectives exist, that terrestrial disputes look trivial when viewed from interstellar scales. The distraction could target specific developments that worry hypothetical cosmic observers. Artificial intelligence research accelerates exponentially, approaching capabilities that could reshape civilization within decades. Genetic engineering advances toward possibilities that could redefine human nature itself. Space technology progresses toward applications that could project human influence far beyond Earth's atmosphere. From a galactic perspective, these developments might appear alarmingly rapid. We've progressed from first flight to interplanetary robots in roughly 1 century, an eye blink in cosmic time. If advanced civilizations required millennia to achieve similar capabilities, our acceleration might seem destabilizing, dangerous, or worthy of subtle intervention. But distraction assumes that slowing human development serves someone's interests, and those interests remain mysterious. What would advanced civilizations gain from delaying our technological progress? Why would they care about the internal affairs of one species on one planet around one ordinary star? The scale mismatch is profound. Any civilization capable of staging interstellar visitors would possess resources and capabilities that dwarf terrestrial concerns. They could colonize galaxy-wide territories, harness stellar energy output, and manipulate matter on astronomical scales. Human activities, however destructive locally, would barely register against such cosmic capabilities. Unless we're missing something fundamental about the value of conscious life, the rarity of intelligence, or the importance of diversity in cosmic development, perhaps consciousness is so extraordinarily rare that every example matters enormously to advanced civilizations. Perhaps intelligence emerges so infrequently that allowing any instance to self-destruct represents intolerable waste. Under this interpretation, 3I-ATLAS becomes an intervention designed to prevent civilizational suicide during our most dangerous developmental phase. The mysterious chemistry captures scientific attention, encouraging international cooperation and resource allocation toward discovery rather than destruction. The limited observational windows force us to develop patience and collaborative planning rather than demanding immediate answers. The psychological mechanism would be elegant. Instead of overt interference that might trigger defensive reactions, advanced civilizations provide engaging mysteries that naturally redirect human attention toward constructive activities. We choose to study 3I-ATLAS because it fascinates us, not because someone commands us to study it. But this benevolent distraction hypothesis encounters the same evidential problems as more sinister interpretations. Current observations of 3I-ATLAS align consistently with natural comet behavior in interstellar environments. No credible evidence suggests artificial origin, technological components, or hidden intelligence. The James Webb spectroscopy reveals carbon dioxide dominance that multiple research teams have explained through conventional formation and processing mechanisms. The Hubble imagery shows morphology consistent with small, icy bodies sublimating under solar heating. The trajectory calculations demonstrate orbital dynamics that match expectations for gravitational interactions in stellar neighborhoods. Scientific institutions studying 3I-ATLAS have maintained transparency about methods, uncertainties, and interpretive frameworks. The Minor Planet Center publishes orbital updates regularly. NASA provides public access to trajectory visualization tools. Research teams share preliminary findings through preprint servers before formal peer review. This open approach contradicts typical patterns of institutional deception. Organizations hiding significant discoveries usually restrict information access, classify research methods, and limit public discussion of findings. The scientific community's behavior regarding 3I-ATLAS suggests genuine discovery rather than managed disclosure. The distraction hypothesis also assumes that terrestrial attention is somehow valuable or dangerous enough to warrant cosmic intervention. But human attention, however intense, operates on timescales that barely register in galactic contexts. Our most sustained focus on individual topics rarely exceeds years or decades. Our collective memory of specific events fades within generations. Even if 3I-ATLAS succeeded in distracting humanity from dangerous developments, the distraction would be temporary. After perihelion, the object will fade from visibility and public consciousness. Whatever terrestrial activities the distraction was meant to interrupt could resume once the cosmic show ends. Unless the distraction serves different purposes, not preventing specific human activities, but demonstrating specific human capabilities. How we respond to cosmic mysteries might provide information about our readiness for contact, membership in galactic communities, or access to advanced technologies. Under this interpretation, 3I-ATLAS becomes a probe in the anthropological sense, an instrument for studying human behavior under controlled conditions. The unusual chemistry tests our scientific methodology. The international observation requirements test our collaborative capabilities. The conspiracy theory generation tests our critical thinking skills. The results so far reveal a species with impressive technological capabilities but uneven wisdom about their application. We can build instruments sensitive enough to detect trace gases around kilometer-sized objects, billions of kilometers away, but we struggle to distinguish reliable information from compelling speculation. We can coordinate complex international research programs, but we also fragment into competing conspiracy communities that interpret identical data through incompatible frameworks. This mixed performance might explain why advanced civilizations, if they exist, maintain distance while monitoring our development. Direct contact could be premature if we lack sufficient social cohesion to handle the implications responsibly. Indirect assessment through phenomena like 3I-ATLAS provides safer evaluation methods. Yet even these sophisticated distraction scenarios assume that human development matters enough to justify cosmic attention. The assumption might be flattering but unrealistic. We could be alone in our cosmic neighborhood, making all speculation about alien intervention irrelevant. We could be so primitive that advanced civilizations don't consider us worth monitoring, let alone manipulating. The distraction question ultimately reflects our difficulty accepting that cosmic events might have no human-centered meaning whatsoever. 3I-ATLAS could be exactly what it appears: ancient ice and rock following gravitational laws, carrying chemical signatures that reflect formation around a star whose name we'll never know, in a planetary system that dispersed millions of years before Earth existed. Sometimes the most radical possibility is that the universe operates independently of human concerns, delivering surprises according to its own schedule rather than ours. Sometimes consciousness encounters phenomena that expand its horizons, not because someone designed them for that purpose, but because consciousness is naturally curious about anything that challenges its existing understanding. The question of why anyone would want to distract humanity assumes that we're important enough to distract. The alternative, that we're simply witnesses to cosmic processes larger than our imagination, might be more humbling but also more liberating. As we approach our documentary's philosophical conclusion, consider that the most meaningful question might not be whether 3I-ATLAS distracts us from terrestrial concerns, but whether terrestrial concerns distract us from cosmic opportunities. Some distractions lead us toward truth rather than away from it. Part 12. Cosmic Stagecraft. The universe, it turns out, has always been in the entertainment business. Long before humans invented theatre, the cosmos was performing elaborate shows featuring exploding stars, colliding galaxies, and the slow-motion ballet of planetary formation. We simply bought tickets much later than the show began. 3I-ATLAS enters this cosmic theatre as an unusual performer, neither the familiar protagonist of solar system drama nor the exotic villain of science fiction fantasy, but something more subtle. A character actor whose presence changes the entire production without dominating the stage. The staging is minimalist, almost avant-garde. No spectacular tail blazing across evening skies. No catastrophic collision threatening global civilization. Just a faint smudge in telescopic images, visible only to instruments sensitive enough to detect its ghostly coma of carbon dioxide and dust. It's cosmic theatre for the scientifically literate, a performance that requires education to appreciate, patience to observe, and imagination to interpret. The costume department has outdone itself with 3I-ATLAS's chemical wardrobe. That carbon dioxide-rich coma functions as both disguise and revelation, hiding the object's true nature while advertising its alien origin. Like an actor speaking with a foreign accent, 3I-ATLAS announces its outsider status through spectroscopic signatures that don't quite match local dialects. The script follows classical dramatic structure: discovery and recognition in Act 1, rising action through summer observations in Act 2, climax at perihelion on October 29th in Act 3. But the climax occurs mostly off-stage, hidden behind our sun's glare when Earth's geometry prevents clear observation. It's a bold directorial choice, building toward a moment we can't fully witness. Unless that's exactly the point of this particular production, traditional theatre assumes passive audiences consuming prepared performances. Cosmic stagecraft might operate differently, requiring audience participation in interpreting ambiguous phenomena. 3I-ATLAS provides raw material for meaning-making rather than predetermined messages. We become co-creators of the narrative, projecting our hopes and fears onto its chemical signature and orbital mechanics. The supporting cast includes Earth's most sophisticated instruments: Hubble peering through visible light, James Webb analyzing infrared emissions, ground-based telescopes tracking position and brightness changes. Each instrument contributes different perspectives on the same performance, like camera angles in film production. The coherence across multiple observation methods suggests either genuine phenomena or deception so sophisticated that it exceeds current human technological capabilities. The production values are certainly impressive. 3I-ATLAS maintains consistent behavior across months of observation, predictable brightness variations, steady outgassing rates, trajectory that precisely follows gravitational calculations. Real cosmic objects often show irregular behaviors that reflect complex internal structures and variable solar heating. 3I-ATLAS's relative consistency could indicate either simple composition or careful engineering. The timing of revelation adds dramatic tension worthy of professional scriptwriting. Discovery in July provides months of anticipation building toward the October perihelion climax. The Mars encounter in early October offers a potential plot twist, high-resolution imaging that might reveal unexpected surface features or confirm expected comet morphology. But cosmic stagecraft, if it exists, operates under constraints that terrestrial theatre doesn't face. The laws of physics cannot be suspended for dramatic effect. Gravitational mechanics follow mathematical certainties, regardless of audience expectations. Chemical spectroscopy reflects actual molecular composition rather than narrative requirements. These constraints mean that staging 3I-ATLAS would require mastery of physics so complete that deception becomes indistinguishable from reality. Anyone capable of such technological achievement would possess capabilities that make traditional concepts of stagecraft obsolete. They wouldn't need to fake cosmic phenomena. They could create genuine cosmic phenomena according to their aesthetic preferences. The audience reaction has been predictably human, professional astronomers maintaining scientific skepticism while pursuing detailed observations, amateur enthusiasts tracking the object through backyard telescopes, conspiracy theorists weaving elaborate narratives around limited data, and the general public oscillating between cosmic wonder and terrestrial indifference. This diverse response pattern suggests that 3I-ATLAS succeeds as entertainment for multiple demographic segments simultaneously. Scientists get rare data about interstellar material composition. Conspiracy theorists get ambiguous phenomena perfect for speculative interpretation. Space enthusiasts get a tangible connection to other star systems. The general public gets a harmless mystery that doesn't threaten anyone but satisfies our collective appetite for cosmic significance. If this were intentional stagecraft, it represents remarkably sophisticated audience analysis. Different groups receive different aspects of the same performance, each finding the level of mystery appropriate to their interests and expertise. Scientists get chemical puzzles. Conspiracy theorists get temporal coincidences. Philosophers get existential questions about meaning and intention in cosmic events. The offstage action during perihelion adds another layer of theatrical sophistication. By positioning 3I-ATLAS behind our Sun during its most active phase, the cosmic director ensures that the climax remains partially hidden, leaving room for imagination to fill observational gaps. We'll know the object reached perihelion because orbital mechanics guarantee it, but we won't see exactly what happened during that critical passage. This dramatic choice, revelation through concealment, reflects advanced understanding of psychological engagement. Total mystery often generates disinterest, while total revelation often terminates engagement. Optimal entertainment provides enough information to enable speculation, but not enough to settle all questions definitively. Yet the most sophisticated aspect of this hypothetical cosmic stagecraft might be its indistinguishability from natural phenomena. If 3I-ATLAS were artificially created, its creators have achieved technological artistry that perfectly mimics cosmic processes we're only beginning to understand. The deception would be so complete that discovering it would require capabilities we don't yet possess. This unfalsifiability makes cosmic stagecraft theories intellectually unsatisfying despite their narrative appeal. We can neither prove nor disprove elaborate deception scenarios because they postulate capabilities beyond our evaluation methods. We're reduced to choosing between competing interpretations based on philosophical preferences rather than empirical evidence. The natural alternative remains more parsimonious. 3I-ATLAS represents what it appears to be ancient ice and rock from an alien stellar environment, following predictable physical laws as it passes through our solar system. Its chemical oddities reflect formation conditions we haven't previously sampled. Its dramatic timing reflects our pattern-seeking psychology rather than cosmic intentionality. But perhaps the distinction between natural and artificial becomes meaningless at sufficiently advanced technological levels. If consciousness can manipulate matter and energy with cosmic precision, then consciousness becomes a natural force shaping cosmic evolution. The question changes from, is 3I-ATLAS natural or artificial, to how much consciousness influences cosmic phenomena at scales we can't yet perceive. The cosmic theatre continues its eternal run, whether we understand the script or not. Stars explode according to nuclear physics, galaxies collide according to gravitational dynamics. Comets sublime according to thermal processes. Consciousness observes, interprets, and occasionally imagines intention where none might exist. 3I-ATLAS performs its role with mathematical precision, releasing gases at rates determined by solar heating, following trajectories calculated by gravitational mechanics, reflecting light according to optical properties established by millions of years of cosmic processing. Whether we interpret its performance as natural wonder or artificial spectacle, it continues the show. Tonight, as we near our documentary's end, consider that the most profound stagecraft might be consciousness itself, the universe developing the capacity to observe and interpret its own phenomena, creating meaning through the act of attention rather than discovering meaning embedded in external events. The stage is vast, the performance is ongoing, and we're simultaneously audience and cast members in a cosmic production whose final act remains unwritten. Part 13. Humanity's Role. We are, it seems, remarkably talented at transforming simple observations into complex narratives. Give us a dot of light moving across the sky, and we'll construct elaborate stories about intention, meaning, and hidden purpose. This talent for narrative creation might be humanity's greatest gift to cosmic consciousness, or our most dangerous delusion. 3I-ATLAS tests this talent in fascinating ways. The object itself is almost boringly straightforward: ice and rock following gravitational laws, releasing gases through thermal processes, reflecting sunlight according to optical physics. Yet we've managed to weave conspiracy theories, alien intelligence scenarios, and government cover-up narratives around these simple phenomena. This creative interpretation process reveals something profound about human consciousness. We don't just observe reality, we actively construct it through the stories we tell about our observations. The same spectroscopic data that suggests natural comet formation to astronomers suggests artificial manufacture to conspiracy theorists. The same orbital mechanics that demonstrate gravitational dynamics to physicists demonstrate purposeful timing to those convinced of hidden agendas. Our role in the 3I-ATLAS story isn't passive observation, but active creation. We're not just witnesses to cosmic events, we're collaborators in determining what those events mean. The object's significance emerges not from its intrinsic properties, but from our psychological response to encountering something unexpected. This collaborative meaning-making has historical precedents that should make us both proud and cautious. Human interpretation of comets has evolved from supernatural omens to gravitational mechanics, from divine messages to chemical laboratories. Each interpretive framework reflected the technological capabilities and cultural assumptions of its era, while revealing something true about both the phenomena and the observers. Medieval Europeans saw comets as harbingers of plague and political upheaval, because their worldview assumed direct connections between celestial and terrestrial events. 18th century astronomers saw comets as gravitational dancers because their mathematical tools revealed orbital mechanics. 21st century scientists see comets as chemical archives because their spectroscopic instruments can analyze ancient ice composition. 3I-ATLAS arrives during an era when our interpretive capabilities have exploded beyond previous human experience. We can analyze the composition of objects billions of kilometers away, track their movements with sub-kilometer precision, and model their formation in alien stellar environments. But our interpretive frameworks haven't necessarily evolved to match our technological sophistication. We still seek agency in coincidence, intention in accident, and human-scaled meaning in cosmic-scaled phenomena. We still prefer stories that provide psychological satisfaction over explanations that provide intellectual accuracy. We still want the universe to care about our concerns, to operate according to our moral frameworks, to deliver meaning in packages we can readily unwrap. The healthy approach to cosmic mysteries requires what scientists call intellectual humility, the recognition that our current understanding might be incomplete, our interpretive frameworks might be inadequate, and our emotional preferences might mislead us about empirical reality. This doesn't mean abandoning curiosity or speculation, but rather holding both lightly, like soap bubbles that pop if gripped too tightly. 3I-ATLAS provides excellent practice for this intellectual discipline. Its unusual carbon dioxide chemistry challenges our models of comet formation without necessarily indicating artificial origin. Its observational timing creates information gaps without necessarily suggesting purposeful concealment. Its interstellar origin connects us to cosmic scales without necessarily implying cosmic intention. The challenge is maintaining curiosity while resisting premature closure. Human psychology evolved to make rapid decisions based on incomplete information, a survival strategy when predators lurked behind every tree. But cosmic phenomena operate on timescales that dwarf human decision-making cycles. Patience becomes a necessary skill for cosmic citizenship. Our cultural memory of comet panics and broadcast frights provides cautionary context for interpreting 3I-ATLAS. The 1910 Halley's hysteria and 1938 War of the Worlds panic demonstrate how quickly astronomical observations can transform into social phenomena. The 1997 Heaven's Gate tragedy shows how cosmic interpretations can turn deadly when they intersect with vulnerable psychology. These historical examples suggest guidelines for healthy cosmic mystery engagement. Prioritize primary sources over secondary interpretation. Distinguish observation from speculation. Maintain skepticism about claims that spike emotional responses. And remember that extraordinary phenomena usually have ordinary explanations. The institutions studying 3I-ATLAS generally follow these guidelines. NASA emphasizes observational data over interpretive speculation. The European Space Agency coordinates international research rather than promoting competitive national narratives. The SETI Institute maintains scientific standards despite institutional incentives to discover extraterrestrial intelligence. But institutional behavior reflects collective human choices about how to approach cosmic mysteries. We could choose sensationalism over science, competition over cooperation, immediate gratification over patient investigation. The fact that we've generally chosen constructive approaches to 3I-ATLAS suggests positive development in our cosmic maturity. Yet social media conversations about 3I-ATLAS reveal persistent challenges. Algorithmic amplification favors engaging content over accurate content, promoting conspiracy theories that generate strong emotional responses while burying technical analysis that requires sustained attention. We've created information systems that reward psychological satisfaction over empirical accuracy. The solution isn't eliminating speculation about cosmic mysteries, but improving our collective skills for evaluating speculation. We need better education about how science actually works, better communication about uncertainty and probability, and better cultural frameworks for holding questions without demanding immediate answers. 3I-ATLAS offers a practice ground for these skills. Its chemistry challenges existing models without necessarily overturning physics. Its timing generates suspicious coincidences without necessarily indicating conspiracy. Its behavior creates interpretive puzzles without necessarily requiring exotic explanations. Our response to this practice opportunity will influence how we handle future cosmic mysteries, which are virtually guaranteed to become more common as our detection capabilities improve. The Vera Rubin Observatory will probably discover interstellar visitors monthly rather than yearly. How we develop institutional and cultural frameworks for studying them will determine whether such discoveries strengthen or weaken our collective rationality. The role we choose to play in cosmic theatre ultimately reflects our understanding of consciousness's place in the universe. Are we passive observers of predetermined cosmic drama, or active participants in creating meaning through attention and interpretation? Are we victims of forces beyond our control, or collaborators in writing the next chapter of cosmic evolution? 3I-ATLAS suggests that the answer might be both. We encounter phenomena we didn't create or control, but we determine what those encounters mean for our understanding of reality, possibility, and our own nature. Perhaps our greatest talent isn't creating compelling narratives about cosmic events, but learning when not to. Perhaps wisdom means sometimes allowing mysteries to remain mysterious, phenomena to exist without immediate explanation, and the universe to be larger than our current capacity to understand it. The comet continues its journey regardless of our interpretations, following mathematical laws older than consciousness itself. But consciousness continues its journey too, learning to navigate between skepticism and wonder, between meaning and mechanism, between human concerns and cosmic scales. Our role in this cosmic production is still being written. Part 14. The Date Ahead. October 29th, 2025, approximately 11:44 Universal Time. Mark your calendars, set your alarms, or simply file this moment away in whatever corner of memory you reserve for cosmic appointments. 3I-ATLAS will reach perihelion, its closest approach to our Sun, at a distance of roughly 1.36 astronomical units. To put that distance in perspective, 1 astronomical unit equals the average distance between Earth and Sun, roughly 150 million kilometers. 3I-ATLAS will approach about 36% closer to our star than we are right now, placing it somewhere between Earth's orbit and Mars's orbit when it swings around our gravitational neighborhood. At that distance, traveling at approximately 68 kilometers per second, 3I-ATLAS will experience the most intense solar heating of its current visit to our solar system. If it behaves like other comets, this thermal stress should increase outgassing rates, brighten its coma, and potentially develop a visible tail pointing away from the Sunday. But if 3I-ATLAS continues defying expectations, October 29th might surprise us in ways we haven't yet imagined. The irony of this cosmic appointment is that Earth will have terrible seats for the main event. Our planet's orbital position on October 29th places us roughly on the opposite side of the Sun from 3I-ATLAS. Astronomers call this solar conjunction, a geometric alignment that makes ground-based observation nearly impossible because the object appears too close to the Sun's position in our sky. This observational challenge has already generated whispers in online forums. They don't want us to see what really happens. The timing is too convenient. Why would an interstellar object arrive just when we can't observe it clearly? These questions reveal more about human psychology than cosmic mechanics, but they highlight how quickly astronomy becomes anthropology when uncertainty meets suspicion. The reality is more mundane but no less fascinating. Solar conjunction occurs when any object's orbital geometry places it near the Sun from Earth's perspective. It happens regularly for planets, asteroids, and comets throughout the solar system. It's not a conspiracy, it's just celestial mechanics playing out according to gravitational laws that predate human civilization by billions of years. But the observational difficulties during perihelion don't mean we'll learn nothing during 3I-ATLAS's most active phase. Space-based instruments like the Solar and Heliospheric Observatory might catch glimpses of the comet's approach and departure. The Parker Solar Probe, currently studying our Sun's outer atmosphere, could potentially detect material ejected from 3I-ATLAS if it ventures close enough to solar orbital regions. The Mars encounter around October 3rd offers the most promising opportunity for detailed observation. When 3I-ATLAS passes relatively close to the red planet, the high-resolution imaging science experiment aboard NASA's Mars Reconnaissance Orbiter could potentially photograph the object with unprecedented clarity. These images might resolve surface features, determine precise size measurements, and reveal structural details invisible from Earth. HiRISE has previously captured images of Phobos, Mars's larger moon, showing surface features smaller than 10 meters across. If viewing conditions align favorably, similar resolution might be achievable for 3I-ATLAS. Such images would either confirm the object's comet-like nature or reveal anomalies that challenge natural origin explanations. However, HiRISE observations depend on complex geometric requirements. The spacecraft must be positioned correctly, the object must be adequately illuminated by sunlight, and atmospheric conditions on Mars must remain clear. Astronomical observation is always a negotiation between scientific desires and physical constraints. The James Webb Space Telescope will continue monitoring 3I-ATLAS throughout its approach to perihelion, measuring how its chemical composition changes as solar heating intensifies. Scientists particularly want to track the carbon dioxide to water vapor ratio. Will it remain constant, or will increasing temperature alter the balance by preferentially sublimating different ice components? These measurements could reveal crucial information about 3I-ATLAS's internal structure. If water ice is buried beneath carbon dioxide ice, thermal penetration might eventually expose deeper layers with different chemical signatures. If the unusual composition extends throughout the object, sustained heating might maintain the current CO2 dominance even at perihelion. Ground-based observations will become more favorable after perihelion as 3I-ATLAS moves away from the Sun and Earth's viewing geometry improves. By December 2025, the object should be accessible to larger ground-based telescopes, enabling spectroscopic studies that complement space-based observations. The extended observation timeline means that October 29th represents just one milestone in a longer research program. 3I-ATLAS will remain detectable and scientifically interesting for months after perihelion, gradually fading as it moves away from the Sun and its coma dissipates. This extended visibility provides opportunities to test various hypotheses about the object's nature. Natural comets typically show predictable brightness curves and chemical evolution as they move through different thermal environments. Artificial objects might show different patterns, irregular brightness variations, unusual spectroscopic changes, or non-gravitational accelerations that indicate propulsion systems. Several research teams have already proposed specific observational tests that could distinguish between natural and artificial origin hypotheses. Light curve analysis might reveal rotation periods and surface irregularities consistent with natural formation processes. Spectroscopic monitoring might track how chemical emission lines change with solar distance. Astrometric measurements might detect subtle trajectory deviations that suggest internal activity or external control. The scientific community approaches October 29th with cautious optimism rather than dramatic expectation. Most astronomers expect 3I-ATLAS to continue behaving like an unusual but fundamentally natural comet. They're prepared for surprises but don't anticipate revelations that would revolutionize our understanding of cosmic phenomena. This measured expectation reflects decades of experience studying exotic astronomical objects that initially appeared to challenge known physics, but ultimately yielded to conventional explanations. Pulsars seemed artificial when first discovered because their regular radio pulses resembled technological signals. Quasars seemed impossible because their energy output exceeded theoretical limits for natural processes. In both cases, expanded theoretical frameworks eventually accommodated the observations without requiring exotic explanations. 3I-ATLAS might follow this pattern, initially puzzling but ultimately explicable through natural processes we don't yet fully understand. Its carbon dioxide-rich chemistry might reflect formation conditions around red dwarf stars, where planetary systems develop different chemical abundances than our Sun's neighborhood. Its approach timing might reflect statistical inevitability rather than purposeful coordination, or it might genuinely represent something unprecedented that expands our understanding of what's possible in cosmic evolution. Not necessarily artificial intelligence or alien technology, but natural processes that operate differently than our limited experience suggests. The date ahead, October 29, 2025, will provide new data for evaluating these possibilities. But it probably won't provide definitive answers. Cosmic mysteries typically resolve gradually through accumulated observations rather than sudden revelations. 3I-ATLAS will likely remain mysterious long after its perihelion passage, continuing to generate questions even as it fades from visibility. Perhaps that's the most appropriate outcome. Mysteries that resolve too quickly often disappoint, while mysteries that persist appropriately often teach us patience, humility, and appreciation for the universe's creative complexity. October 29th approaches whether we're ready or not. The comet doesn't consult human calendars or wait for human permission. It follows ancient gravitational trajectories established millions of years ago, indifferent to our theories about its purpose or origin. We can choose how to meet this cosmic appointment, with anxiety or anticipation, with skepticism or wonder, with conspiracy theories or scientific curiosity. The choice says more about us than about 3I-ATLAS, but that might be the point of the entire encounter. Some appointments are worth keeping simply because they remind us that the universe still schedules surprises. Part 15. Closing Meditation. Here, at the edge of sleep and speculation, we find ourselves exactly where we began, staring at something we can't quite explain, wondering whether the universe has better timing than coincidence should allow. 3I-ATLAS continues its ancient journey, indifferent to our theories about its purpose, following gravitational laws older than consciousness itself. We've spent these quiet hours exploring frameworks for understanding cosmic mysteries, conspiracy theories, and scientific hypotheses, distraction scenarios, and natural explanations, human psychology and alien intelligence. Each framework illuminates different aspects of the same fundamental question. What does it mean to encounter something genuinely unknown? The facts remain reassuringly stable throughout our speculation. 3I-ATLAS follows a hyperbolic trajectory that indicates interstellar origin. Its carbon dioxide-rich coma suggests formation in an alien stellar environment. Its approach to perihelion on October 29, 2025, will provide opportunities for enhanced observation despite Earth's challenging geometry. No credible evidence suggests artificial origin, technological components, or hidden intelligence. Yet the questions persist because questions often outlive answers. Even if future observations conclusively demonstrate that 3I-ATLAS is natural phenomena, ancient ice sublimating under solar heating according to predictable physics, we'll still wonder about the next interstellar visitor, the next cosmic surprise, the next intersection between human curiosity and universal creativity. Perhaps that wondering is the point. Perhaps consciousness evolved not just to solve mysteries, but to generate them, to find puzzles in phenomena that might otherwise pass unnoticed. 3I-ATLAS becomes significant not because it carries messages from alien civilizations, but because it carries opportunities for conscious reflection about our place in cosmic evolution. The distraction question transforms under this perspective. Instead of asking whether 3I-ATLAS distracts us from terrestrial concerns, we might ask whether terrestrial concerns distract us from cosmic opportunities. Instead of wondering who benefits from our attention to celestial mysteries, we might consider how attention to celestial mysteries benefits our psychological and spiritual development. Cosmic perspective has historically served as antidote to provincial thinking. When humans first glimpsed Earth from space, the fragile blue marble floating in infinite darkness, political boundaries became invisible, and national conflict seemed absurdly petty. 3I-ATLAS offers similar perspective expansion, a reminder that our solar system receives visitors from distances so vast that terrestrial geography becomes meaningless. This perspective shift might be exactly what consciousness needs during periods of technological and social turbulence. When artificial intelligence development accelerates beyond our ability to predict consequences, cosmic timescales remind us that patience often proves wiser than haste. When political polarization threatens social cohesion, interstellar visitors remind us that we're all passengers on the same planetary spacecraft. The universe has always been our most patient teacher, delivering lessons through phenomena that operate on scales larger than human planning can encompass. Galaxies collide over hundreds of millions of years, demonstrating how apparent catastrophes can create new possibilities. Stars exhaust their nuclear fuel and explode, scattering heavy elements necessary for planet formation and life chemistry. 3I-ATLAS participates in this cosmic pedagogy by arriving at a moment when we're technologically capable of studying it but interpretively unprepared for what we might discover. The gap between observation and understanding creates space for both rigorous science and imaginative speculation, a reminder that knowledge accumulates through patient attention rather than anxious interpretation. Tonight, as we prepare to release our hold on these questions, let's acknowledge what we've held in balance: facts and meanings, observations and stories, wonder and analysis. The sky has offered us both, and we've received both without requiring immediate resolution. This capacity to hold uncertainty alongside curiosity might be consciousness's greatest gift to cosmic exploration. The facts remain stable as we settle into sleep. 3I-ATLAS follows its calculated trajectory toward October 29th perihelion. Its carbon dioxide-rich chemistry continues confounding models based on local solar system formation. Its hyperbolic path confirms interstellar origin. These observations require no belief or interpretation. They simply describe what instruments have measured and mathematics has confirmed. The story frames we've explored, distraction theories, theatrical scenarios, cosmic tests, remain exactly what they are: frameworks for meaning, making rather than empirical claims. They help us organize our responses to uncertainty without claiming exclusive truth about cosmic intentions. We can appreciate their psychological function while maintaining healthy skepticism about their factual accuracy. Perhaps permission to let go comes naturally now. Mysteries don't require constant vigilance to remain mysterious. 3I-ATLAS will continue its ancient journey, whether we're watching or sleeping, thinking or dreaming. Our attention honors the encounter but doesn't sustain it. The comet carries its own momentum through space and time. Gratitude flows easily toward the instruments and teams that make distant worlds feel accessible. The ATLAS survey that first detected this visitor, the Minor Planet Center that tracks its motion, NASA and ESA missions that provide space-based perspectives. the SETI community that asks profound questions about cosmic intelligence. These networks of curiosity and technology enable consciousness to reach beyond planetary boundaries, to touch phenomena that originated in stellar environments we'll never visit. Consider one final thought experiment as your mind prepares for rest. If 3I-ATLAS were indeed a distraction, perhaps it's distracting us from forgetting wonder. In a world increasingly focused on immediate concerns and technological acceleration, cosmic visitors remind us that vastness still exists beyond human scales. They invite us to remember that consciousness participates in processes larger than civilization, older than species, more patient than any human timeline. This remembering might be exactly what we need, not distraction from reality, but connection to larger realities that contextualize human experience within cosmic evolution. When we gaze at interstellar visitors, we practice perspective that transcends provincial boundaries and temporal anxiety. Let's breathe together now, allowing these reflections to settle into whatever corner of awareness holds cosmic appointments. Breathe in slowly for 4 counts. Hold gently for 4. Release softly for 6. And again, in for 4, hold for 4, out for 6. Letting each breath carry away the need for immediate answers while preserving appreciation for beautiful questions. As your breathing finds its natural rhythm, rest assured that no credible evidence suggests danger from 3I-ATLAS. Current observations best fit natural explanations, an interstellar comet with intriguing chemistry, following gravitational laws toward its closest solar approach. Tomorrow's research will continue building understanding through patient observation rather than anxious speculation. Envision now the comet's faint veil dissolving into night, not disappearing but blending with darkness that connects all distant lights. Let your questions dim with it, not vanishing but settling into the quiet corners where mysteries keep comfortable company with sleep. October 29th approaches whether we're ready or not, and readiness often comes not through preparation, but through acceptance. Some answers aren't meant for tonight.